Here we are, 8.3, trig derivatives. We are going to learn the derivatives for all 6 trig functions. So we're going to start off by asking, what is the derivative of the sine of x? And you see just below, I've graphed what we call the first period for sine x. Just the lighting here. The first period for sine x starting at 0, ending at 2 pi, like so. So what we're going to do is we're going to try and answer this question graphically. So I don't know if you do that much, if you did that sort of thing back in 121, but this is, I find the best way to explain the derivative for sine x is to look at the graph and then just sort of analyze it. So we can notice, hey, there is, sorry for the shadow, there is a horizontal tangent line here at pi over 2 and another one at 3 pi over 2. So what I've done, I've we'll kind of go step for step. If there's a horizontal tangent line there, the slope of that is 0, right? At those two locations. So down here, if I'm graphing the derivative, then I know my derivative value is 0 at each of those points. So if the tangent line has a slope of 0, then my derivative value is 0. That's what I would graph. So then what about other points? So it turns out if we were to look at the slope of the tangent line right there at 0, so it kind of goes up and beyond, turns out the slope of that line is exactly 1. So I would put a 1 down here. Now that's not immediately obvious, especially from a hand-drawn graph. But if you wanted to, you could graph sine x maybe in Desmos or something like that and just kind of look at it. Does it seem to be like a slope of 1? You could even, graph the line y equals x and see that that would be the tangent line there. Hey, if the slope is 1 here at 0, same thing's going to happen back here at 2 pi, right? Because it's repeating itself. That's going to be 1 as well over at 2 pi. What about right there in the middle? What's the slope of that line? Well, it's just doing the opposite of what it did back here. That slope is -1. Let's label them all. So here at pi, I would plot -1. And maybe you can tell what's going on here. Sorry for all the shadows. You can tell what's going on here down in the derivative graph if we put all that together. Do you recognize this graph? And now this is incredible. That is the graph for cosine of x. It begins at 1, then it goes through 0, -1, back to 0, back to 1. It goes through 1 period, we say, for cosine of x. Now, at the end of the day, you don't have to be able to explain why this is true. You just need to know this statement right here, that the derivative of the sine of x is incredibly simply cosine of x. That is amazing. Okay, pretty cool. Let's talk about the next derivative, and well, of course, that's going to be cosine of x. What's the derivative for cosine of x? Now, if the derivative for sine of x ended up being cosine of x, we might be able to take a pretty good guess at what the derivative for the cosine of x is. Maybe it just goes, it goes back to sine x. But let's look at it graphically and then we'll know for sure. And it turns out, I'll just give it away, it's actually not sine of x, but it's really close to that with one adjustment, if you will. Okay, so I've got the graph for cosine of x. We just saw this thing. Hey, let's analyze this derivative in the same way. So I can tell the tangent line right here is going to be 0. Same thing over here. That tangent line is going to have a slope of 0, I should say. And down here at the bottom, that tangent line has a slope of 0. So I'm going to go back here and kind of do the same thing. Going to go step for step. So if I had 0, 0, 0, well, I'm going to plot those each 0, 0, 0 there for my derivative graph. You might think, oh, sine of x does this. That's true. It is 0, and then it goes up, and then it hits, and then it comes down. But, okay, let's keep going. What is the slope of the tangent line here? And what is it here in cosine? And, well, it's doing something similar to what we just talked about. That's -1. Here it's +1. So let's plot those. Let's plot the -1 at pi over 2. And let's plot the +1 at 3 pi over 2. And oh, and we can tell now it's not sine of x. Sine of x would go up. This comes down. But it does take the same curve. It's just doing the opposite of what sine of x does. So it turns out this graph is negative sine of x. Whatever the value would have been, take the negative, and it's doing the opposite. Okay, again, we don't need to be able to explain this. At the end of the day, we just need to know this statement right here, that the derivative of cosine of x equals negative sine x. Very close to sine x, just a negative in front. Okay. So we're going to just sit on these two derivatives for now. The derivative for sine of x and cosine of x. We're going to discover the other 4 trig function derivatives after a couple of examples. I think it's nice here. Just kind of pause, try this out. So a couple of examples here. We're asked to differentiate. We've got f of x equals 6 cosine of x. Let's take the derivative. Well, we know that 6 is just going to carry along. We know the derivative for cosine of x is negative sine x. So we might as well take the negative that would have been here, and it's all going to multiply. Negative 6 sine of x is our derivative there. Okay. Pretty simple. Let's do a harder one. How about y equals the sine of 4x? Now you can tell that we've got a chain rule, right? You may have learned it by thinking of the outside function and the inside function. That's the way I learned it. That's the way I always teach it. If you were to label those, of course, what's in the parentheses is the inside, so that means the sine is the outside. So taking the derivative of the outside, well, that's going to be cosine, and then, okay, we'll follow the chain rule. So here we go, derivative of the outside, cosine, and we repeat the 4x. Then we multiply by the derivative of the 4x, the 4. And we probably want to rewrite that answer a little bit nicer. Let's put the 4 in front, 4 cosine of 4x. There it is. Okay, how about one more? just to see this, obviously we can combine now sine and cosine derivatives any way that we might have done derivatives before and all the other rules that we know. Chain rule's a big one. What if we do the square root? G of x equals the square root of cosine x. Well, there's another chain rule going on here. Maybe, though, we want to think of it like this, right? Cosine of x raised to the 1/2 before we start thinking of how our chain rule works. And writing it this way, it's real clear. Cosine of x is the inside. The 1/2 power is the outside. So here's our chain rule. The 1/2 comes down, of course, drops to a negative 1/2, and we repeat the cosine. But then we need to multiply this whole thing by the derivative of the cosine, negative sine of x. And it doesn't look all that pretty, but I went ahead and said, you know what, if this was your final answer if this was a test and all I said was differentiate, and this, you just went ahead and circled that without cleaning anything else up, I would be perfectly happy with that. It's clear that you know how to take that derivative. However, oftentimes we like to simplify our derivatives, especially if we're then going to set it equal to 0 or who knows what we might do. So a better way, a simpler way to write that would be like this. I know my cosine to the negative 1/2 can drop to the denominator, and I can even rewrite as a square root. Since I've got the 1/2 here, that 2 can drop down, and let's just move that negative sign up to the top. And that would be, there's the simplified version. Okay, let's stop this video here. So we did a couple with chain rule and then a simpler one to get started. Of course, there might be product rules involved, quotient rules, anything goes, any kind of combination. We're going to look at the other 4 trig derivatives in the next video.